All right, now that we've finished our Bible reading, name a more entertaining 4-hour class. You can't. You just can't. All right, so we're going to talk about Firebase. Okay, so right now, if we were to draw a little picture of our app, we have our travel hack app right here. All right, so, and this guy is storing some stuff locally inside of a couple of linked lists.
But it's only temporarily storing it, correct?
Correct.
Okay.
Yep, so this guy's storing some stuff locally inside of a couple of linked lists. When we close our app and then reopen it, everything's gone. Now, there are some options for storing stuff locally on the device. All right, but the first problem we're trying to overcome here is, how do we make data persist between runs of the app? All right, so we have to have something that lives outside of local memory in our app that will let things persist. Now, the old, let's call it mobile app way of doing it would be to have something called SQLite or SQLite or something, blah, blah, blah. All right, so let's talk about different kinds of databases here. So in general, I'm going to say, how do we make data persist between runs of the app? We can say files. We can say relational databases. And we can say NoSQL databases. And then off of that, I'm going to talk about real-time databases. All right, so in the old days, we would have said, hey, we're just going to store some stuff to a file. We'll just open the file up, write some stuff in some sort of proprietary format, let's say. And next time the app starts, we'll read in from that file. However, we stored the stuff in that proprietary format. Maybe it's like a CSV, comma separated values, something like that. Could be the way you store the stuff in the file. You could also do like an Excel file, things like that. But in the old days, you would have maybe had proprietary text files where you just choose how you want to organize your data in that file, and you're the one who coded it, so you make sure your program writes it to it that way, and you make sure your program can read it in that way. But that's still only a local file. Okay. Now the problem with files is we're going to say these guys are slow, proprietary, and let's call it not searchable. Can't really do much with them, all right, unless you build custom code specifically to search your file type. All right, now relational databases. So here on campus, what are we using? SQL Server?
Oracle and SQL Server, yeah.
Okay, Oracle and SQL Server, okay. Both of those are relational databases. So relational databases, we would say, are somewhat old school. So I'm not going to go too deep into database stuff here, but in general, relational databases have the goal of not duplicating data when possible. All right, so we have a whole bunch of individual tables that have data in them, and then we try to associate certain tables with other tables through primary keys and foreign keys and things like that, such that At most, data gets stored in one place. And then we can reconstruct our data by doing joins and stuff like that through tables using SQL. So SQL is a query language used to interface with relational databases. All right, and depending on, let's call it the quality of your database or the goals of your database, some subset of the full SQL capabilities are supported. For instance, Oracle supports standard SQL and then has some of its own SQL efficiency functions and things like that to allow you to do powerful things more quickly, that kind of stuff. But Oracle would be, an enterprise level database that's very expensive and all this stuff. Whereas a free database like MySQL, something like that, is going to support the SQL queries that most people will ever use, let's say. All right, so, but the difference between the free database and the really, really expensive database, at the end of the day, comes down to how many transactions it can handle at the same time. Amazon not going to run MySQL. Okay, Amazon is probably, actually Amazon was probably on Oracle. I bet you that they are on something somewhat internally proprietary now. They might still have some Oracle stuff, but I bet you they're moving off of Oracle.
They're using Postgres.
On their own. They're using Postgres on their own cloud computing.
They forked Postgres and something. And actually,
but they're running on their own cloud, on their own Amazon Web Services.
They learned the hard way though why you can't get off Oracle on the last Prime Day if your cloud froze, because just like what you said, Oracle can handle OLTP really well. Postgres can't. It took down one of their data centers.
Yeah, but I mean, the reality is these companies almost have to get off of Oracle or MySQL Server or whatever, because there's too much competition between these companies, and if your product is reliant on another business,
Amazon will figure it out. Like they'll make Postgres do it, but like they learn like the enterprise DBs like DB2, SQL Server, and Oracle. Like those are extraordinarily more mature than the open source ones.
Yeah, this is the database he's talking about, PostgreSQL, but they're running it on top of their Amazon Web Services, so they're running it on top of Elastic Linux for
and they
support.
It, so I mean
they're doing their own tweaks.
They're doing their own thing under the hood, and it's probably pretty awesome.
All right, so relational databases. Let's just we'll fill in a couple of gaps here. So we're going to say SQLite, MySQL, Microsoft SQL Server, and then Oracle. You got some other ones you can throw in there. I roughly have these listed from like lowest power to most power, let's call it. So SQLite, this is single user, few transactions.
Embedded.
Yeah, it's embedded, comes on most of our mobile stuff. So basically your bare minimum that supports SQL so that you can query it. All right. MySQL probably is most popular in terms of total installs in the world or something like that. This guy is free, fine for most things. Even medium-sized companies probably can run on MySQL just fine. There's nothing wrong with it. It's just going to come up short on performance for Amazon-y type of enterprises, that kind of stuff. MySQL Server, this is considered an enterprise database. So this is enterprise level for Microsoft shops. So if all your other crap is Microsoft, you're going to run Microsoft SQL Server. It's just the punchline. Oracle, I mean, if you talk to Microsoft, they probably say they're just as good. Historically, Oracle has been considered to be kind of the highest performing enterprise database at the cost of requiring some expertise in order to get the most out of it, because they have some specialized SQL stuff that allows it to there's a proprietariness associated with it. So let's just call this most powerful and move on with life. Okay, doesn't matter for us. Punchline for us is all these relational databases are built on top of this idea of SQL. Okay, now I mentioned that relational databases have the goal of not duplicating data when possible. Right? This is because when they became popular, it's when hard drive space and memory was really, really, really expensive. We didn't have a lot of space. So we had to find the most powerful way to store our data in the smallest footprint and still have it be queryable and all that stuff. So we could really say that the goals of relational databases are no longer important. It's probably a fair enough thing to say. That idea of not duplicating data. Now, then you might say, well, why haven't we just gotten rid of these relational databases then? That doesn't mean they're bad. It just means their initial goal is no longer really a problem. You know, the initial problem that we're solving isn't really a problem. But you have huge, huge, huge companies that have large databases with zillions of tables, and all these things are already connected together and already queryable and things like that. Wouldn't make any sense for them to convert over to a more recent version of a database when what they have now does its job. And frankly, it has so many years of evolution, let's say, on those databases that from a performance perspective, even the most modern real-time database stuff is maybe only going to be able to compete with Oracle in certain verticals, certain ways. We'll get there, but it's not like this is antiquated. Okay, but if you're starting a project today and you're not already married to an older relational database or something like that, you might consider a more modern NoSQL database. All right, NoSQL database. So popular one of these is called MongoDB. Okay, so MongoDB is a NoSQL database. What we can really say is has the goal of speed rather than storage footprint. Data is stored, let's say data is typically stored in JSON.
Is this what Hadoop is usually built on?
Yep. So data is typically stored in JSON. Who's worked with JSON before?
Very, very.
Okay, you know what JSON is, roughly. So JSON is a, so for instance, let's say that we were representing one of our loyalty programs in JSON. We might say name is Chase Ultimate Rewards. Bank is Chase. Points is 1,000, something like that. So that is a representation of a loyalty program object in JSON. Do you know what JSON stands for?
Object notation.
Yep, JavaScript object notation. Do you know where it came from?
Douglas Crockford.
Well, do you know when we started? Well, we started using JSON for data representation. We took that from JavaScript because JavaScript represents their objects. So the object-oriented version of JavaScript represents their objects as JSON. This is how you define a class in JSON, or in JavaScript rather. Okay, so this is a notation. So what was in the middle here? So we'll kind of say that we kind of had these are the dark ages. Object-oriented databases. Tried it, sort of worked, never took off. This was kind of during the time period where object-oriented programming languages were super awesome, so they figured, well, why shouldn't we have object-oriented databases? Well, what's an object-oriented database? It's a database that stores objects as opposed to a database that stores your data split across multiple tables and stuff like that. great idea, but implementation wasn't really there. And because memory was still pretty expensive, people gravitated towards relational databases. All right. Well, now with NoSQL databases, we're right back to the whole idea of object-oriented databases, but now it makes sense because we don't have to worry about data footprint and stuff like that, and we're not necessarily competing against relational databases. It's really kind of a new approach to databases that is maybe more app-focused rather than service-focused. All right, so I think it's probably likely, and this might be, I mean, this is speculation. Right now, if you were to go out and get a job as like a database administrator, a DBA, you would likely be managing a enterprise relational database, Oracle SQL Server, stuff like that. Right now, there likely isn't really database administrator positions for NoSQL databases. These tend to be more for production applications as opposed to managing huge data farms. Something along those lines, let's say. All right, so NoSQL database, MongoDB is a pretty popular one. There's some other ones, but let's just say that's, if you're thinking about NoSQL databases, you're probably thinking MongoDB. All right. Store stuff as JSON objects, so now we can actually store an entire object. So if we think about it from our Android app perspective, it would be cool for us to say, here's a credit card, I want to store it, and store the whole credit card. Instead of saying a credit card, we're going to insert into table credit cards, have it auto count or something like that, and say name is equal to this, and bank is equal to this, and so on and so forth. So, you know, it's instead of having to represent your storage into the database as an SQL string, we can now store it in the database as a JSON representation. All right, we're going to see how that translates into reality today. All right, so these are NoSQL databases. All right, then we have this idea of a real-time database. We're going to call this a NoSQL database on steroids. And we're going to say this implements the observer design pattern. All right, so we've talked about several design patterns in here so far, right? Okay, what's the first design pattern we talked about? MVC? Okay, model view controller. Good idea to separate your logic from your interface from your data, but we haven't really done the data part yet. We're about to. What's the second design pattern we've looked at in here? What's core? Singletons. We've looked at the singleton design pattern that says it's a good idea to store stuff that needs to be accessed by several different objects, several screens in a single place. This last one is the observer design pattern. Now, the observer design pattern says it's a good idea to be productive while waiting for some event to occur rather than sit there and just wait.
Spitting gift.
Right. Okay, so if you're waiting for a phone call back for a job interview or something like that, and you just sit there by the phone, you know, this is easier said than done, but, you know, you'd really be better off going in, cleaning house or working on homework or doing something else productive, and then when the phone rings, you become notified that the phone is ringing by the ringing, and you go and answer it. You interrupt what you're doing, go and answer it, deal with the phone call, then come back. Okay, that just makes sense, right? Be productive while you're waiting for some event to occur when you don't necessarily know when it's going to occur. Real-time databases provide this mechanism. We're going to look at Firebase in here, which is a real-time NoSQL database. I'm going to say owned by Google. Firebase was created by somebody else. Google acquired them. Google is currently all in with Firebase. They've upgraded all of their, basically Firebase is Google's cloud computing platform. This is in competition with like Microsoft, Azure, Amazon, web services, those types of things. All right. So Google's all in with Firebase. In fact, they do all of their push notifications now for Android through Firebase push notifications, which is probably, I mean, if you're writing apps for both iOS and Android, I always use Firebase as for my push notifications because it supports both, where iOS push notifications does not support Android tokens. So you can do it once, use it on the Firebase side and have it work for everything, or you can do it on iOS and then do it the Android way, which is the Firebase way. Something like that. Now, we're going to also say that Firebase is a PaaS. We've seen those letters before? Platform as a service. So that's platform as a service. Microsoft Azure is a PaaS. Anybody know what Amazon Web Services is? Yeah, IaaS. So this is infrastructure as a service. What's the difference? What's the difference between a platform as a service versus an infrastructure as a service? Service.
Yes. So if you got Azure, you don't have to worry about servers, or it's AWS, you can actually manage the servers, so you get the infrastructure stack.
Okay. I think that's mostly true. Not that you can manage the servers, you do manage the servers. Yeah, so Amazon Web Services says, hey, we'll give you all the power you need. Here is your Linux installation. Go. Anything you want, put on there. We'll give you the elastic memory, elastic computing infrastructure in the back. If you need to scale up to have 4,000 processors, we got you. No problem. Okay, but you have to solve all the problems using yourself. Platform as a service like Azure or Firebase, you have to do things the Azure or the Firebase way. Okay, so if Firebase says, here's the way you store in our database. You write it this way, you read it this way. That's the way, their way or the highway. Where with Amazon Web Services, you can use MySQL if you want. You can install Oracle on there. Yeah, you can install Oracle on PostgreSQL. You can choose your database. You can use MongoDB if you want, relying on their infrastructure, their servers and stuff like that live behind the scenes for the power. Generally speaking, we would probably say something along the lines of platform as a service is easier to use, but you might be trading off some performance potentially. Infrastructure as a service gives you more flexibility at the cost of being more difficult.
It's like more raw.
It is raw, yeah. Here's your server, go. Do whatever you want. So for instance, Netflix used, I think they've moved completely off of it now, but Netflix was delivering their service using Amazon Web Services for years. Why do you think they did that rather than using something like Microsoft's Azure, which wasn't around then, but a different cloud computing platform?
Well, if they're experimenting on how they have to, don't they have a special way of like streaming their video and stuff?
Yeah,
So, like,
Netflix has a secret sauce.
right. So like if they want to experiment with that on just using their servers, they can do that. Whereas like Azure, Firebase.
Yeah. So Netflix secret sauce is their compression algorithms.
Yeah.
They're doing some special stuff to get 4K video or 1080p video streamed to your computer without losing too much quality on slower than it should be internet connections, right? With millions of streams every second. So they're doing something pretty special, right? With an infrastructure as a service like Amazon Web Services, they had the flexibility to bring their proprietary invention into reality using Amazon's hardware. Whereas if they were using which Firebase didn't exist then. It was Google App Engine at the time. But if you use their cloud computing platform, which is a platform as a service, video compression was done the Google video compression way. You didn't have that flexibility to do it the way you wanted to do it. Okay? But now we see that Amazon has their Prime Video, so they are in the video streaming business. So it would be in Netflix's best interest to not be reliant on Amazon stuff for their streaming service to stay alive. It's like, hey, we are getting pixelated here. Yeah. So in any case, let's call it the high level thing here. But Firebase is a real-time database. It stores NoSQL stuff. It's owned by Google. And when I say real-time, it allows us to set up listeners to listen for changes to the database at different points. Different, let's say, access points maybe in the database. So it allows us to be very granular and say, I care if something here changes. I care if something here changes. I want to know only if something 9 levels down actually changes. You could set up 3 different listeners for that. We'll see some examples of that. So, and really a good way of looking at Firebase as the problem it helps you solve initially, and I'm going to talk about this out loud before we actually write some code for this. How many of you have ever had to write a chat server? Okay, remember your chat server?
Yeah.
Remember how much that sucked?
Yes.
So chat servers are hard, which is funny because you go back and you think about the early days of the internet, that's what people did, right? They got in chat rooms and talked to people and that kind of stuff. So if we're writing a chat server, you have your server sitting up here. Okay, then you have your clients that are connecting to this server. So on and so forth. All right, so this server handles, if this client wants to send a piece of information, if I say hello, hello gets sent up here, then this guy broadcasts it to all their connected clients, right? Okay, but maybe he doesn't broadcast it back to himself, otherwise he'll see an echo back on his own screen. So maybe it says you say this, and then everybody else says that Mike said this, that kind of stuff. All right, so we have this one central guy here who is reliant on me sending stuff here, and then these guys getting responses. Now, these guys do not follow the observer design pattern. Instead, these guys are sitting there, sitting on the edge of their seat, just waiting for the next thing to come in. But they actually have to do 2 jobs, right? So this client application listens for user input, and then also listens for new messages. So each of these clients is doing 2 separate things. So this could be 2 different threads of execution. So on one hand, this client is listening for the user to type something on their keyboard and press enter, in which case they then send something up to the server. On the other hand, their application is also sitting there just waiting for the server to send something to them, which might be a new message that was broadcast from somebody else that they then update on their screen. Right? 2 separate things are happening here in order to pull this off. There's a lot of moving parts to get something so simple like a chat server working. All right? Firebase allows your clients to register with Firebase and say, I am interested in all new messages. Okay, they could just say, look, whenever this database gets a new message, I want to know about it. So this guy would set up a listener here. This guy would set up a listener here. This guy would set up a listener here. And then they can go about their day, doing their own thing, not worrying about it. And if this guy sends a message to Firebase, Firebase then automatically broadcasts it to everybody else. You don't have to write it. It does it. So Firebase broadcasts changes at all points in the database to anybody who's interested in them. So you can actually create chat type applications with Firebase very easily relative to the way it used to be. You don't have to create your own second thread or second process in order to do this. You just tell your client, like in our case, it'll be our app. We just say, look, I'm interested in knowing when there's new messages. So I want to keep an eye on the new message queue in the database. So let me know if anything updates there. Now I'm going to go about my business. It does all the magic of creating the thread and maintaining the communication and all that stuff. So this guy pushes that information to you rather than you constantly checking on it. Okay? So Firebase, that's what it means to be real time, that aspect of it. All right, so let's talk about integrating Firebase into our Android app. So I'm going to go to firebase.google.com. And that's going to take me here, create an account, use your Gmail account or whatever, and eventually you'll just go and click on Go to Console. You'll probably not have any applications yet. All right, so I already have some stuff in here. I'm going to add a project. Now, you can actually do this from this side, or you can do it from Android side. So Android Studio, which is made by Google, knows how to natively talk to Firebase, which is also made by Google. So they have a Firebase assistant in there. I usually prefer to build my my project on the website and then connect the application to it. But I'll point out where you could have done it from the other side. So I'm going to say add practice, or add project rather. And we're going to call this guy CSC518 travel hack, something like that. Okay. Now, what I'm doing here is I am creating the project itself. I haven't dictated that I'm making a database yet, because Firebase is Google's cloud computing platform. It's not just for databases. It's also for machine learning. It's also for data storage, images, things like that. All sorts of different things it does. Compute power. Okay, so I'm going to create this project. All right, my new project is ready. I'll hit continue. It'll take me into my project. Notice over here on the side, I have authentication, I have database, I have storage, I have hosting, I have functions, I have machine learning kit, and then here's some other stuff I can do in here with ads and stuff like that. All right, what we're interested in right now, we're not going to worry about authentication, although Firebase has built-in authentication for usernames and passwords and all that stuff. So it handles all that stuff for you. But we're just going to be interested in databases for right now. So I'm going to click on the link that says database. Now, Firebase has this new thing called Cloud Firestore. It's their updated real-time database. I haven't used it yet, and it's not fully integrated into Android Studio anyways. It literally just came out of beta like in the last 2 weeks. So we're just going to pretend like it doesn't exist. We're going to just look at real-time databases for right now. But I'm going to say create database. All right, it's asking me, do I want to start in locked mode or in test mode? We're going to say test mode. And the difference there is locked mode says only authenticated users can change your database. Well, we're not going to be adding authentication to our app yet. Okay, so therefore, we're going to start in test mode so our app can actually read and write from our database since we're not logging in. You change it later. Yep. So I'll say start in test mode. I'll go ahead and click enable. We are going to double check on that because sometimes that doesn't actually take. So we'll make sure that that gets set. All right, so this creates our empty database for us. I'm going to go ahead and this drop down up here where it currently says Cloud File Store or Firestore. I'm going to hit the drop down. I'm just going to say Realtime Database. So I'm going to switch over to that. All right, it's going to give me something that looks like this. Now, just to double check on the test thing, I'm going to go ahead and click on, I think it's in Rules. Okay, yeah, actually it didn't do it correctly. So default security rules are locked from access. So even though I said test mode, it didn't put it in test mode. So I need to come in here and I need to change both of these to true. And then I'll hit publish. All right. And that why did it even ask me? Like, look, I don't care what you answer to this question. I'm going to do whatever I want. But now what's interesting is I think recently I have created a database on here where it did work. So it might legitimately be a coin flip.
Everybody try it.
It would be kind of funny. But in any case, you just want to make sure the rules for your database are set to true for read and write. That way it allows our app to just publicly read and write from it. And anybody else who has your API key can sit there and mess with your app too, or mess with your database too. So this isn't responsible. Yeah, but this is going to make our life easier for right now.
Yeah.
Got it? Okay. So we're back here to the data side of this. So this is where our database will actually live. So we're going to pause this for right now, and because we've created our project, we've created our database. Now we're going to go teach our Android project how to talk to this dude. Okay? So I'm going to go back over to Android Studio. And up top here, we have a drop down called Tools. And inside here, you have a thing called Firebase. Click on that. All right, the one we care about is Real-Time Database. So we have analytics, cloud messaging, authentication, real-time database storage, blah, blah, blah. All right, but we're going to care about Real-Time Database, so we hit that guy. Little link here says save and retrieve data. All right, so now the first thing we're going to do is this thing that says connect to Firebase. This is going to allow our app is going to go and download this special file, and I'm going to kind of show this to you here in a second. So I'm just going to right click out here, and I'm going to say, where is it showing? Reveal in Finder? Yeah, Reveal in Finder. Okay, so here is my folder that has that stuff in it for right now. Okay, I actually need to go up a level, I think. Oh, this will be okay. I think it'll show up in there. All right, so right now I don't have any special JSON file in here. We'll come back to that here in a minute. So I'm going to go ahead and I'm going to say connect to Firebase. You don't have to open up in your Finder. I'm just showing you what it's about to create. Okay, so when I actually tell this guy to connect to Firebase, it's going to do some magic over on Firebase and then download this JSON file that has all my information, how to talk to my specific Firebase project we just made. So I'm going to click connect to Firebase. So it's going to start connecting to Firebase here. Now notice I can go ahead and create a new Firebase project myself right here if I wanted to, but we already did that. Now I'm already signed in with my Gmail account, so you might have, before it pops this up for you, you might have to log in with whatever your account you used for your Firebase thing. But I'm going to click on choose an existing Firebase project. And here's our CSC518 travel hack project we just created. Okay, it already showed up in there. Okay, but rather than create a new one up here, which you can do, I already did it on the website, so I'm just going to choose an existing and then select the one I chose. And then I'm going to say connect to Firebase. So it says connecting app to Firebase. It's doing some magic behind the scenes. And eventually we'll get a little connected thing there. Now let me see. So I'm going to go back in here. I don't see it there. Here it is. This file right here, this Google Services JSON, is what it just downloaded. You don't need to worry about it, but that guy has like my app ID in it and all the magical API keys to make my app talk to the right project up on Google. Okay, so that was the result of clicking this button. All right, next thing is we're going to add the real-time database to our app. Now, there's currently a bug with this on Mac. I think it'll work on Windows machines, if I remember correctly. Okay, so I'm going to click on Add Real-Time Database to your app. It's saying, hey, we're going to make some changes to your build.gradle file for the project level as well as your app build.gradle file for the entire application. We're adding some plugins to this to teach this dude how to talk to Firebase. All right? You just have to say, I accept those changes. I'm happy with that. So it's going to go and do its thing. And then what we're going to see is as it's trying to build here, it's on mine, it's going to fail. If you're on a Windows machine, it probably succeeded. Okay? So I got a thing down here that said, fail to resolve Firebase database 15.0, blah, blah, blah. So I'm going to go ahead and open the file that it's complaining about, which is this guy right here. And the line it's complaining about is this guy down here. I just need to take that piece off of it. The colon 15.0.0. The string that they tried to add to it added 2 different versions instead of just one. It's, like I said, I don't think it's broken on the Windows version.
No one's figured that out yet?
They just don't, they seem to release updates to the Firebase stuff for Windows quicker than Mac. But I'm not, at that point I feel like I'm making excuses for them. It's been there for a little bit. This is not like last week. This is.
Do they know about it?
Yeah, there's tons and tons of threads online.
Okay.
Yeah, I mean this is like at least a 6-month.
Okay.
That you would think a little tiny patch, like look, we're gonna just,
Three
yeah, we're gonna take the end of that string off.
Millions.
Yeah. All right. So I've done that, and now if I click on, so notice right now it thinks that my dependencies are set up correctly, so it shows green here right now, but my Gradle file is not correct. So I'm going to say go ahead and try again now that I updated that piece. Now my Gradle builds, but this dude's not convinced everything's fine. No biggie. We're good. Okay, so if you're on a Mac, expect the final thing here to not be convinced I've successfully added it because it's looking for the exact bad string that it put in there. Okay? And this file is my app Gradle file. So this is inside of Gradle scripts. And here is build Gradle, the app level one. That's the last line it put in there. Okay? If you're on a Windows machine, I think it does it correctly the first time around. Are you following it?
Yep.
Worked fine? Yeah. Okay. So now, and then here's the little blurb here about configuring your Firebase database rules to make it public. We already did that. Okay. All right. So now we want to be able to write some stuff to our database. So we're going to steal a little of this code over here. I'm going to go ahead and copy it, then I'll tell you what it's doing. All right. So I'm going to just highlight that because I realize that's too tiny for you to see. And I'm going to close this. I'm just going to do this inside of main activity. All right, so right here at the top of my main activity, before I start doing any of my linked list stuff, I'll just paste these couple of lines in. All right, so the first thing is we have an object type called Firebase Database. If you press Alt-Enter, highlight on that and press Alt-Enter, it'll go ahead and import com.google.firebase.database.firebase database. This is one of the libraries we just had integrated into our code. This will not be available unless you embed that add real-time database stuff like we just did. That's what downloads this API for us to have access to it. All right, so there's our Firebase database. We also need this thing called a database reference. So again, just highlight it, press Alt-Enter. And I'm going to say import class, and that will import com.google.firebase.database.database reference. All right, brings that guy in. All right, now he seems pretty cool with all the error messages. So these are the 3 lines that I've added to my program that I actually had to type in. I copied and pasted them, but I actually had to type these in. Okay? Now, let's talk about what these guys do. First of all, when I get, this is a pointer to my database. So it's Firebase database.getInstance. So this is a class method owned by the Firebase database class that will give me the instance associated with my database for this project. And since I hook this guy up to my 518 travel hack database, it'll be that instance. So if I'm drawing the picture here, I have my Firebase database up here. I now have a little variable called database. And this guy is a pointer to my database up here in the sky. Okay? That's how I talk to my database. Okay, I can duplicate this guy as many times as I want, but notice that pointer only exists one time. So this gets back to our static versus non-static thing. I have to ask Firebase database to get me my one and only instance to my database.
So it's a static.
Yeah, correct. I mean, I can have 50 variables that all have this same instance in it, but that's one pointer. Every one of those 50 variables will have the exact same memory address. They all point to that one single database, which is my guy in the cloud, which is hooked up to my code through that Google Services JSON file that was downloaded. Okay? The next thing here is we have this thing called a database reference. Now, I'm actually going to create 2 different database references here just so you can see how this works. So I'll call this guy myref2, and I'll call this products. All right, so then we'll say, inside joke. So then we'll say myref set value. So what's happening here is we have 2 variables, myref and myref2. So we're presuming there are like tables in my database, one called message, another one called products. So if we think about our database up here, maybe we have a, and it's not really a table, you can almost think of it as like maybe a folder in NoSQL. But we're going to have a message folder, and then we're also going to have a products folder like that. Okay, now we have a couple of variables. I have myref, and this guy points to specifically to the message reference, or the message table, folder, whatever, in my database. And then I have myref2, which is pointing to the products. Okay? Like that. Now notice that I get my pointer to my database first. Then I ask my database to give me a reference to message. I ask my database to give me a reference to products. All right? So myref and myref2 were created in terms of this database pointer. This gave us pointers to our specific folders or tables in our database. So now I'm going to say myref.setValue hello world, and I'll say myref2.setValue, and we'll just have this guy say LOL. Okay. Get a pointer to the database, point to the places we want to either, well, in this case, where we want to write to in our database, set the value at those references equal to some values. This is all happening inside of onCreate in my applications. This is before we click on anything, right? Just as a reminder here, my database currently looks like this. If I go ahead and hit play, is my app launching? There's my app launching. There's our hello world and our LOL. So two things have gotten written into our database.
So the my reference, could you write the references within reference?
Yep.
Did you write folders within folders?
Yep. So I could say database.getReference that, and then I could say database reference. The best way to show this to you will be to introduce the push function first. So I'm going to say myref.push.setValue, myref2.push.setValue. Now, as it stands right now, if I ran my program 1,000 times, my database would look exactly like this. I am literally going to the top level message, setting the value there to hello world. The top level, products, setting the value to LOL. No matter how many times I run my program, I'm just going to keep overwriting those two things. What push does is it generates a unique key that allows me to have multiple records with and be able to differentiate them through a unique identifier. I'll show you that here. So go ahead and run this. All right, so notice that message now has a unique key here that says hello world. Products has a unique key that says LOL. If I launch my application again, we will get a second product and a second message.
So essentially it's logging it.
Well, yeah, but what push does is push generates this random sequence. It gives me a unique identifier for that particular.
Right, because that hello world is actually a new hello world. That world, that's not the same one. It's technically a new one. Because now the old way, it's just reading in and saying it's the same hello world, or is it writing over it? Like so. Say
The old way would be writing over it.
The old way is writing over it. Okay.
Yeah,
So
this one, push gives me this piece. So this is actually at message / this guy equals hello world.
So really, so for this app, you need the push notification for the last entry that was in there. If you're pushing it every time you get a credit card, you press that send to the first page.
It's not always the last thing that's in there. For right now, just think of push as being a way of generating a unique key for an entry.
Okay.
I think that'll be all you want to think about for right now. Now, you can also go a step deeper, so I could say something like myref2.child, and I don't know, we can say woot.push.setValue to Mike.
Just like XPath for.
Sort of. Yep. All right, so this is saying go to myref2, which was products. Add a child to that, like a subdirectory, called woot. Push onto that, a unique identifier. Set the value Mike. So if I go ahead and run this, we'll see products update. Okay, so notice that products has a new thing here, but then we have a woot child of products, and inside of there we have a unique identifier, and it says Mike.
Can we look at the raw JSON in the database?
It's not stored in raw JSON yet. And actually, the answer is yes, you can. it'll make more sense when we actually have an object in there, but you can.
If that's later on, we can go.
You can export the JSON from it, but I want to know if you can view it in there. We'll see it at some point. Okay. So far so good? All right. So now I want to show you how to do a listener. All right. Doing this off of, actually, we can do it from here. So I go to Tools, Firebase. This will just open up that menu. I'll click on Realtime Database, Save and Retrieve Data, and I'm just going to steal this code here, then I'll explain it to you. All right, so we're going to do this on myRef, which is our message top level thing. And we're doing something called Add Value Event Listener. This is our observer design pattern. Okay, so this guy is a value event listener. So I'm going to go ahead and hit Alt-Enter, and that'll import that. So value event listener comes from Google, Firebase, Database, value event listener. So these are all Firebase stuff. All right, data snapshot, we'll talk about that in a second, but Alt-Enter on that. This will import data snapshot. And then I'm not going to use this log D thing. Just for the sake of showing you this listener thing for right now. I'm going to take those two things out, take that out. Okay. All right, so let me walk you through this and tell you what's going on. So this is kind of similar to what we did for an array adapter, all right? But when we made our custom array adapter, what we actually did is we created a second class, a whole separate class called my custom array adapter, which extends array adapter, okay? And then what we did is we specifically overrode a couple of methods in there, the get count and the get view. We actually could have done that in using this model. So rather than creating a separate class, we could have actually said, we're going to create a new array adapter, but override those methods in line. Would have been a lot more difficult to do that with an array adapter since we had to modify it fairly heavily to work with our linked lists. But for this guy, this works pretty well for this, although we could make this into its own class, and maybe I'll show you at some point how to do that, but you pretty much know how to do that from our array adapter example. So I'm telling myRef, which is our endpoint for message, I'm saying I want to add a value listener, value event listener there. I want to know when values change. Okay? This guy's going to be a new value event listener, but I want to, inline, make a couple of changes to that dude. Firstly, I want to override the default onDataChange method to do something that I want to do with the data. Secondly, I have to override the onCanceled method in the event something bad happens. All right, this is usually if like an internet, data failed to read, internet connectivity is down, something like that. Okay, so I'm actually not even going to do anything inside the error for right now, but on data changed, we're going to say string value is equal to data snapshot.getValue, and this guy is of type string. And then I'll just go ahead and say system.out.println. And I'll put a bunch of asterisks here. I'll concatenate onto that value. Okay? So, this guy is an asynchronous call, or a non-blocking call. This is an example of the observer design pattern. We are interested in changes to our database. We are telling our reference, let me know if something happens in message, because my ref is our pointer to message in my database. I want to know if any data changes in there. When it does, this onDataChange method will get called. And what am I going to do? I'm going to read the value that gets read in, and I'll spit it out to the screen, proving that I noticed the change. Okay? But when I add this value event listener to this guy, my code will go on. I'll go ahead and create my linked lists and do all this other stuff. It's just sitting there waiting for that phone to ring. Remember earlier we were talking about like you're waiting for the call to come in? Okay? It's just waiting for the database to change. No harm, no foul. So I'm going to go ahead and run this. And what you'll see actually is when the app first launches, we're going to write a couple things to the database anyways. But, in fact, actually, I'll choose not to write to the database. I still have my two references. I'm just not actually writing anything to the database right now. We already have some stuff in the database. I'm going to go ahead and write it the first time, because I'm going back to a much simpler version of my database. So I'm actually just going to delete all the stuff that's in there. Start with a fresh database. All right. So I'll go ahead and set my two references. I'll write two things to it. Each time I write something, this guy will actually get called. But then I'm going to show you more examples of this. All right, so let me go to logcat. Let me go to verbose system. Actually, we can just probably do the asterisks guy there. So there's our hello world that got written. Remember, we're only looking at changes to message, not to products. Make sense? I set up my listener only for my database ref1, not ref2. Ref2 was for products. So this guy sees that hello world is in there. Now remember, go ahead.
It's an on-change listener?
It's, yeah, anything changes.
So even though nothing changed when you instantiated the listener?
It did change.
It did change.
I wrote to it up here, right here.
Okay, but I guess...
So it changed. I mean, this is before I did the listener. If I had done these two lines after it, it wouldn't have happened. Okay, but what I wanted to show you here is if I take these two things out, you're going to see that it still gets called because it shows you the current data that's in there too.
So when you add a listener, it's going to get called to show you what's in there
initially, and then every change after that.
Okay, what if you what if you added the listener and it was an empty store? Would it show you anything?
No, there's nothing in there.
Okay.
Yeah, so see, it just showed me hello world even though I didn't write to it again. Okay, so I'm going to go ahead and just clear this out. Code's still running here, right? I'm just going to change the data that's in here. So I'm changing the database itself to Woot. This guy noticed. Woot. All right? So that's why chat servers are so much easier to write with Firebase, because they will broadcast changes to anybody who's interested. That make sense? So, a couple little connections, and we're good to go with that stuff. All right, questions about that? We understand kind of basic Firebase connectivity stuff. We're about to do some cooler stuff with Firebase, but let's take we'll take 10, and then we'll write something. We'll write an object to the database. All right, so take 10 minutes.